Dear students, welcome to ACE Academy and ACE online platform. And now that we have this PYQ series is headed for almost conclusion, and you are left with only 10 days for the examination, and I believe that all of you have been able to maintain the momentum, preparation momentum consistently. So let's get started with the session, and today with the subject is theory of machines. So my name is Mohammad Waheedullah and I am the faculty at ACE Engineering Academy. So here, if you observe the marks distribution over the years, it is ranging from maximum marks to 14 to minimum marks 1. So predicting how much weightage would be given to this subject is very difficult. So this is the variation, and we cannot conclude anything from this variation. Now if you go through the examination, that is, in the examination the questions are framed in such a way that the calculation effort is sometimes minimal also. So you should try to solve the questions with minimal calculation effort. Maybe sometimes there are some questions which may require somewhat rigorous calculation, but overall the paper will be having less calculations. Alright guys, let's get started with the PYQ series. So here is the first question. The kinematic planar chain shown in the figure is dash. So here if you observe, they are asking us to calculate degree of freedom. So first thing, this would be link number 1, this would be link number 1. So wherever the fixed link we are finding, mark it as link number 1. And if you observe, this mechanism is used in our daily life purpose. Okay, so this mechanism will provide a scissor kind of an action. So if this is link number 2, then this would be also link number 2. This is the extension of link number 2. And this mechanism we are using in the traditional elevator doors. You can see that. And even sometimes this mechanism is also used as a barricade on the roadside. You will find that. Okay, so now let's get started. So this is link number 2, and this would be link number 3, this would be link number 3, and this is link number 4. This would be link number 5, link number 5, 6, 6, this is 7, link number 7, this is 8, this is 8, this is link number 9, and this is link number 10. Total we have got 10 number of links. Now here the number of joints. So this is J1. Here at this node we are able to find link number 1, link number 3 and link number 4. So we are finding 3 links, which means 2 pairs are formed. You can say between 1 and 4 it's a prismatic pair, and between 3 and 4 it's a revolute pair. So I'll simply name it as J2 and J3. This would be J4, J5, J6, J7, J8, J9, J10, J11, J12 and J13 it would be. Now you can recall the Grubler's equation, since there are no higher pairs included in the mechanism. So we can straight away use the Grubler's equation, that is degree of freedom is equal to 3 into n minus 1 minus 2j. So this is 3 into number of links is 10, 10 minus 1 minus 2 into 13 it is, which is 27 minus 26, which is equal to 1. So when the degree of freedom is equal to 1, it is a completely constrained mechanism. It is single input, single output kind of a mechanism. And here if you check with the options, It is mechanism with 1 degree of freedom. Option C is the answer. Alright. So let's go to the next question. The number of degree of freedom of a 5-link mechanism with 5 revolute pairs is dash. This is another simple kind of a problem, and here what I want to say is that you will find the questions in the ISRO paper as well as in the GATE paper almost of similar pattern. Maybe, I mean, it could be repetition also. So maybe small change in the numbers would happen, but almost similar patterns is being found in ISRO. So if you are preparing for GATE, automatically it's easy for you to crack the ISRO exam as well. The efforts would be less. Now coming back to this problem, the number of links is 5, number of joints is also 5, you can count it, and degree of freedom for such arrangement, that is equal to 3 into n minus 1 minus 2 times of j, that is 3 into 5 minus 1 minus 2 into 5, which is equal to 12 minus 10, which is 2. So whenever the degree of freedom is greater than 1, then it is unconstrained mechanism. Okay, and if the degree of freedom is 0, then we call it as structure. So option D is the answer for this question. Now let's go to another question. So here it's given about a circular disc of radius r, and it is rolling without slipping with a velocity v and the magnitude of the velocity at point P as shown in the figure. So here it is a case of rolling motion. So when it is rolling, it is a combination of translation plus rotation. So you can solve this problem by using I-center method. You can solve this problem even by using the vectors. So anyways, I mean, the same efforts will be applied whether you opt for either I-center method or whether you opt for, even if you opt for what we call vector method also. So now here the velocity of point P we are required to calculate. So here this is making an angle of 30 degrees. So here at the center of mass will be undergoing translation. So velocity, that is VCM, will be there, and here at the point P will have the velocity which is responsible for translation. Okay, and the velocity which is tangential to the point P will be responsible for rotation. So here for pure rolling motion, we know this condition, that is VCM is equal to R times of omega. Okay, so now here I can write even this also as VCM, and which is equal to R times of omega. So the angle subtended between these two vectors is how much? So if the POP, let's say it is making an angle 30 degrees with the horizontal, and the line normal to OP will make the angle of 60 degrees with the horizontal. This would be 60 degrees. Now you can simply apply the parallelogram law of vectors and calculate. So here velocity of point P is equal to, that is root over VCM square plus VCM square plus 2 times of, that is the formula is R square plus R square is equal to, that is P square plus Q square plus 2PQ, cosine of the angle. So 2 times of VCM square into cos 60 degrees. So upon solving this, we would be getting the answer as root 3 times of VCM. That is at the point P, the velocity will be root 3 times. That is option A is the answer. And let me just extend the question. Let us try to capture the other points as well. So here at the point of contact, the velocity will be 0. here the velocity will be 0. At center of mass, it will be straight away equal to VCM, and at the topmost point, it will be 2 times of VCM. Okay, so this is how the velocity gradient will be established across the diameter of this body. So you can memorize this, and if you remember this triangle, then you can calculate the velocity across the diameter very easily. Okay, so now after this, let's move to another question. So here is also another question, and it is a little bit complex linkage given, and here they are asking you to calculate once again the degrees of freedom. So the fixed will be always treated as link number 1, and this would be link number 2, this is link number 3, sorry. So this is link number 3, and piston is link number 4, and this would be link number 5, and this would be link number 6. Okay. So now let me count the number of joints over here. So number of links, we have got it as n is equal to 6. So here you can realize this is a crank slider mechanism with a common piston. Okay, you are able to realize that it is a crank slider mechanism. Both the connecting rods are connected to a common piston. So next we have number of joints. So this is revolute joint J1, this is another joint J2, and this is another joint J3, this would be J4. Now here at this node, especially the students are prone to commit mistakes. Okay, so let's count how many number of links do we have at this node. At this node, there is link number 1, that is the fixture, that is link number 4, it is piston, link number 3 is also there, and link number 5 is also there. So if there are 4 number of links at one node, then there are 3 joints that are formed. There are 3 joints that will be formed. So please remember this statement: if n number of links are connected at one node, then n minus 1 number of joints are formed. This statement you can memorize. Rather than counting and making out the combination, instead count the number of links and apply this statement, then you will get the answer straight away. So here we have got 4 joints, and at this node, since the number of links are 4, 3, 5, 4 and 1, 4 links are there. So number of joints, that is J5, J6 and J7 it would be. So number of links is 6, number of joints is 7. So here degree of freedom, that is equal to 3 into 6 minus 1 minus 2 into 7, which is equal to 15 minus 14, that is equal to 1. So degree of freedom is 1. Okay. So this is also another kind of question. I mean, similar kind of question, but more or less we are able to find this is the 3rd question in the ISRO paper. So 3 questions have been asked from the mobility analysis. Next question. This is from the ISRO 2019, and here just by seeing the arrangement you can realize that if you find this meter per second, it is understood that it is relating to velocity analysis. So now that when you are attempting a velocity and acceleration analysis question, just remember that the question will be definitely a special case. The question will be definitely a special case because the time allotted is very, very small, and within that allotted time you are supposed to identify the existing arrangement you have to map this existing arrangement with any one of the special cases. Remember that even same thing happens in the gate examination. So you don't have a question, you don't have a question where the calculation gets more lengthier. All these special cases, or the question will be framed in such a way that within 2 to 3 minutes you will be able to crack the problem. It is just that you need to be thorough with the basics. Alright, so let's get back to the problem. Here it says about the rigid rod PQ shown in the figure, and it is connected to 2 sliders at each end through pins. The slider can slide along P and R, PR and QR. These are the guideways. The velocity of the slider P is 4 meter per second, and the velocity of the midpoint of the rod PQ at this instant is dash. They are asking you what is the velocity of the midpoint of the rod. So here in this problem, here the velocity of point P is 4 meter per second, and let's try to resolve. This is the line of stroke of the piston, guys. Okay, this is the line of stroke of the piston. This is the solid link, that is PQ. So now this 4 meter per second has to be resolved along the link PQ. So here, since it is forming an equilateral triangle, the angle, this would be 60 degrees. And here if I mark the horizontal, okay, so with the horizontal, this is going to make an angle of 60 degrees, the alternate angles, okay, and you are able to see this is 180 degrees. So the angle subtended by the velocity vector with the horizontal is also 60 degrees. All right, so now you can resolve this velocity vector along the rod PQ. So this vector, one of the velocity would be along the rod, another would be perpendicular to the rod. Another one would be perpendicular to the rod. So even the angle subtended here, with if I extend the rod on the other side of the velocity vector, this angle comes out to be 60 degrees. So this is 4 cos 60. This is 4 cos 60, and this will be 4 sin 60. All right. Now the Q is going to move like this. Okay, Q will be moving like this. So I need to resolve Q along the rod and perpendicular to the rod. So this is VQ, this would be VQ cos 60, and this would be VQ sin 60. All right. So now if I isolate this rod PQ, I am able to find the two velocity vectors that are perpendicular. One of them is VP, or that is VP sin 60. Another one is VQ sin 60. And if we consider translation, if we consider a case of translation, velocities at all the points has to be same. So now I can write a case of translation, that is velocity, that is V translation, that is equal to 4 cos 60 is equal to VQ cos 60. So VQ will be equal to 4. VQ equal to 4 it is. Let me just check here. Yeah, VQ is equal to 4, and 4 meter per second it is. 4 meter per second it is. Now here this would be 4 sin 60. All right. The velocities are same in magnitude, which means the midpoint of the rod will be becoming the center of rotation. The midpoint of the rod will be becoming center of rotation, and the midpoint of the rod will be in pure translation. It will be in pure translation. No rotational component of velocity will be present. So velocity of the midpoint is straight away equal to, that is V translation, which is nothing but 4 cos 60 it is. That is equal to 2 meter per second. That is equal to 2 meter per second. That is option C is the answer. Okay. All right. Let's go to the next question. Yeah. So here it says 4-bar mechanism with dimensions indicated and the standard units of length. Choose the type of mechanism for the given arrangement. So here if you apply the Grashoff's law, Grashoff's linkage, here this is 3 is L minimum and this is L maximum and this is P and this is Q. So here if you apply the Grashoff's law, that is L minimum plus L maximum is less than P plus Q. That is 3 plus 7 is less than 6 plus 5. This is a class 1 linkage and we are fixing the L minimum, then the result would be double crank mechanism. Result is double crank mechanism. Okay. So this is another type of question from the Grashoff's law and we have seen even from velocity analysis. Now let's see another question. Yeah. Here it says, which of the following mechanism provides an intermittent motion? So intermittent motion is provided by the Geneva mechanism. Okay, this is simple question and this Puy-Cellular mechanism is meant for exact straight line mechanism. Exact straight line mechanism, whereas option A and D is relevant to approximate straight line mechanism. These two are going to give you approximate straight line mechanism. So whenever you are trying to solve any question during the revision, especially try to cover up all the possible options, okay, so that you will be just exploring the information or new information, or it's just one kind of revision. So this practice has to be followed when you are doing the revision, not when you are attempting the test. Okay. All right. So next let's go to the next question. So here the piston of an engine moves with simple harmonic motion. The crank rotates at 120 rpm. The speed of the crank is 120 rpm and the stroke is 2 meters. 2r, that is equal to 2 meters. The velocity of the piston when it is at a distance of 0.8 meters from the center. All right. So now here if we observe the velocity, the piston displacement equation we have written like this in the textbook: L plus R minus of L cos beta plus R cos theta, something of this type. I mean, if you are using this equation to solve the problem, then it's going to kill the time. And here in the question straight away it is mentioned that the motion is simple harmonic motion. Okay, and the data relevant to length of connecting rod is not at all available, so no need of using this formula. As the time constrained or time is limited, we cannot go with this. We can approximate the above relation to R into 1 minus cos theta. R into 1 minus cos theta. So here the distance x is measured from the inner dead center. So here x I can write it as R minus d. Here it is saying 0.8 from the center. It is not specifying inner dead center or outer dead center, it is specifying from the mid position. Okay, so it would be R, that is 1 meter from the mid position, because stroke length is 2 times of R. So 1 minus 0.8, which is equal to 0.2. That is the value of x. 0.2 is equal to 1 times of 1 minus cos theta. So here if I try to solve it, this is cos theta is equal to 0.8. So if cos theta is 0.8, then sin theta will be root over 1 minus cos square theta. So 1 minus of 0.8 square is 0.36 and under root of that is 0.6. So you can see the calculation is very simple. And if I differentiate the above equation, that is v is equal to r times of derivative of 1 is 0 and cos theta derivative is omega into sin theta. So r is anyways 1 meter and omega will be 2 pi into 120 by 60. 2 pi into 120 by 60 into sine 60 is 0.6. It is 0.6. Okay, so answer is given in terms of pi, so we don't have to bother about pi. So this is this would be 60 ones, 62s, and this is 2 into 2 into 2s are 4. 4 into 0.6 is 24 or 2.4 times of pi. 2.4 times of pi meter per second would be the answer. That is option B is the answer. So you can see here how that complex equation is being approximated to a simple equation just by using this assumption. Okay, so this is how the problems, I mean within that limited time frame you should be able to recall and read it properly, and it comes by practice only. Okay, let's go to another question. Yeah, so now these are the questions what we have been seeing with from the mechanism chapter, and next we will take up the questions from the gears chapter. So here it says that if the two gears have a moment of inertia I1 and I2 respectively, and they are in mesh with a speed ratio of omega 2 by omega 1, that is equal to n, the equivalent moment of inertia for the gears referred to first one is dash. So two gears are in mesh. Okay, let's say the small one is the driver, and we are required to calculate the equivalent inertia. What is the inertia of this total arrangement? All right, so here if we realize, or if we do the force analysis, that is here the torque T is applied. When you are applying the external torque T, the inertia of the gear is going to oppose. That is I1 theta 1 double dot. This is going to oppose. And now between the gear and pinion there is a contact. So there will be definitely a contact force which is also going to oppose this. There will be a contact force which is opposing it. Let's call it as F1. And adjacent to gear, the same force will be there and acting in opposite direction, and this is what we follow in the other basic subjects also, that is transferring of reactive forces. So this is, let's call it as F2, but F1 and F2 both are equal. Okay, so here for the gear we can write the equation, that is applied torque T is equal to I I1 theta 1 double dot plus the contact force or the tangential force F1 into R1. All right, so now here for the gear 2 I can write it as F2 into R2 is equal to I2 into theta 2 double dot, that is angular acceleration of the gear. So here in the case it is a case of rolling motion, so we write it as R1 theta 1 is equal to R2 theta 2. If I differentiate it, that is R1 theta 1 dot equal to R2 theta 2 dot. If I differentiate it further, R1 theta 1 double dot is equal to R2 theta 2 double dot it becomes. Okay, so omega 2 by omega 1, that is theta 2 dot by theta 1 dot is equal to n, and this is also equal to R1 by R2. Okay, so basically n is nothing, but also you can say one way, I mean based on this arrangement you can say it's a gear ratio also. Alright, so here we can write, or we can replace here F1 with F2, or else F2 is equal to I2 times of theta 2 double dot by R2, and we will be getting this as T is equal to I1 theta 1 double dot plus I2, that is we will be getting I2 by R2 theta 2 double dot. Theta 2 double dot can be replaced with R1 theta 1 dot by R2. Theta 2 double dot can be replaced by R1 by R2 times of theta 1 double dot. So let me replace that, and here theta 1 double dot by theta 2, so this is once again R1 by R2. So theta 2 double dot can be written as n times of theta 1 double dot. Okay. So now just a minute. So theta 2 double dot can be written as theta 1 or n1 times of n times of theta 1 double dot. Theta 1 double dot, and here I have got R2 in the denominator and R1 will be there in the numerator. R1 will be there in the numerator. These two terms can be replaced with the n. So in short, the torque equation becomes I1 plus n square times of I2 into theta 1 double dot, that is angular acceleration. So the answer is I1 plus n square times of I2. Option D is the answer. Similar kind of question was also even asked in the GATE examination. So go through this question thoroughly, very conceptual, and then you are seeing the analysis related to even the gears. Okay, let's see the next question. Two meeting spur gears have 40 teeth and 120 teeth respectively. The pinion rotates at 1200 rpm and transmits a torque of 20 Newton meter. The torque transmitted by the gear. So it's here you can see the size is 1:3. So when you are increasing the size, the torque is proportional to perpendicular distance or distance from the center of rotation, perpendicular distance from the center of rotation. So if the size is increased by 3 times, obviously the torque will be increased by 3 times. So here the applied torque is 20 Newton meter. The torque at the output will be getting it as 60 Newton meter. Option B is the answer. Okay. Let's see another question. So this is a epicyclic gear train, and wherein you are supposed to perform the velocity analysis, and here there is a tabular method available, but you can go by the relative velocity method, and the equation is very easy to write. So let's get back to the question. Planetary gear is in contact with the fixed gear as shown in the figure. The number of rotations made by the planetary gear for one revolution of the arm. So the arm is going to make one revolution, and what is the number of rotations made by the planet, and the sun gear is fixed. Okay, so let's write the equation. Gear ratio, we write it as gear ratio or velocity ratio. We write it as velocity of the output element. Let's say the output element is planet, divided by velocity of input. Let's say sun is the input, is equal to the speed is inversely proportional to the number of teeth. So here it is a case of external gearing. I need to add here the negative sign, and the teeth of sun will be in the numerator as it is inversely proportional, divided by teeth of the planet will be in denominator. And now in this I have to just subtract the speed of the arm. That's all. That's all. The equation is done, and with this equation just put on the values, the problem is completed. So now if let's do the substitution over here. So ns is 0, so np we need to calculate, and arm is 1 minus 1, and this is minus zs, that is minus 75 by 25. All right, so here we would be getting this as np minus 1 is equal to, this is minus 1 into minus 3, which is 3, and np is equal to 4. 4 revolutions will be completed by a planet when we give 1 revolution to the arm. Option B is the answer. Okay, let's see another question. Which of the following statement is false? A reverted gear train is the one in which the first and the last gear are on the same axis. Reverted gear, the first and the last gears are same axis or coaxial. This is the condition for the reverted gear. This is a correct statement. Next, statement option B, that is train value of the gear is the ratio of product of driven tooth numbers by the product of driving tooth numbers. So train value, we are writing it as the product of driven tooth numbers by driving tooth numbers. Okay, and let's see the option C. The planetary gear train is the one in which the axis of some of the gears may have motion. Yes, axis of the gear is going to revolve, and it is also the planet is going to rotate about its own axis, and it is also going to revolve. So statement C and statement that is option A, both are correct. A compound gear is one in which has 2 or more gears on each axis. So it is going, the compound gear is having 1 or 2 or more gears could be the answer. Yes, even statement D is also correct. So coming back to statement B, that is train value of the gear is the ratio of product of teeth. So train value, in short, we write it as omega of output divided by omega of input side. So whenever we are writing this in this format, the teeth of input members will be reflected in the numerator, and the teeth of output members will be reflected in the denominator. That is for the train value. So it says that the train value is the ratio of product of driven member teeth. In the numerator we are finding driving member teeth. So statement B is the answer. That is the incorrect statement. Okay, let's see the next question. Yeah, so next question is from the vibrations, and here it says a mass m is attached to a light string, oscillates with a period of 2 seconds. If the mass is increased by 2 kgs, the period increases by 1 second. The value of m is dash. So time period, you know the formula, that is 2 pi into, or 1 by 2 pi into m by k it is. So here the mass is modified, not the stiffness. So first it is the time period, that is t is proportional to root m. So t1 by t2 is equal to root over m1 by m2 it is. So here it says the time is 2 seconds in the first case when the mass is root m1, and if the mass is increased by 2 kgs, that is m1 plus 2, the time increases by 1 second, that is 2 plus 1 it is, that is 3. So now try to you need to just solve for m1, that is 4 by 9 it is, 4 by 9, and this would be m1 by m1 plus 2 it is. So that is 4m1, we'll be getting this as 4m1 plus 8 is equal to 9 m1. So this is equal to 5 m1 by 8. So 5 by 8, which is equal to 1.6 kgs approximately. So 5 ones are 5 and say 6 will be there. Yeah, 1.6 kg will be the answer. Option B is the answer. You can see the calculations. Okay. Next question. So a cantilever beam of negligible weight is carrying a mass m at its free end, and it is also resting on an elastic support of stiffness K1 as shown in the figure below. If K2 represents the bending stiffness of the beam, the natural frequency of the system is dash. So here, if the beam is getting, if the mass is producing a deflection, let's say it is going down, so the deflection of the beam and the compression of the spring, here both these members are arranged in the parallel actually. They are arranged in the parallel. And if you want me to describe how they would be in series, then beam and spring and the mass is not at the interface of two structural members. Mass would be on the one side. Then in such case, the spring and beam will be treated in series combination. So here it is a case of parallel combination. So option C, that is K1 plus K2 by m, that will be the natural frequency. Omega n, we know this formula, root over K equivalent by m. So it is a case of parallel, here these two are in parallel combination. Okay. Moving to next question. With the symbols having usual notation, the single degree of freedom system. So here let me just rewrite this equation. Mx double dot plus Cx dot plus Kx is equal to F times of sine omega t. This is the equation. This is the equation. And this equation is representing what? Free vibrations with damping. If it is a free vibration with damping, then the equation is mx double dot plus Cx dot plus Kx it is. And if it is free vibrations without damping, then it is mx double dot plus Kx equal to 0. Because C is representing damping. Damping means loss in energy. Forced vibration with damping. Yes, here this is called as external excitation. Okay, so it is a case of forced vibration with damping. Option C is the answer. And option D, if I say, option D if you want me to write, then it would be mx double dot plus Kx equal to F times of sine omega t. That's all. Okay, so for this question, option C is the answer. Now let's move to the next question. In the two rotor system shown in figure, I1 is less than I2. The mode of vibration is dash. So it's a case of torsional vibration. So natural frequency in that case is given by, that is torsional stiffness Kt divided by I it is. Kt, that is, we can write it as G into J divided by L. G into J divided by L. So if I substitute this in the equation, that is omega n is equal to that is G into J divided by I into L. So from here we can say that I is inversely proportional to L. L is not the length of the shaft. L is the location of the node. L is the location of node. Remember that. So the rotor which has got highest inertia, the location of the node will be closer to that. Okay. The rotor which has got highest inertia, the node will be closer to that. I'm sorry, with the as per the diagram, the node should be somewhere closer to I2. So here it says that option A, between I1 and I2, but nearer to I1, no. I1 is smaller. Between I1 and I2, but nearer to I2. So the rotor which has more inertia, it will pull the node closer to itself. Remember that. Option B is the answer. In the viscous damped vibration, the logarithmic decrement value over 5 vibrations is found to be 8.11. What is the viscous damping factor of the vibrating system? So here you can recall this formula, that is 1 by n into log of x naught by xn, and that is equal to 2 into zeta, 2 pi zeta by 1 minus zeta square. This is how it is, or let me just check. Or else if you take the logarithm of this, that is x naught by xn equal to this is n times of zeta into omega d, it is into td, n times of zeta into omega n into td it is. Okay, so x naught by xn is given as 8.11 and n is equal to 5. Zeta we need to calculate, so omega n and td we can write it as, that is 2 pi by that is omega n into 1 minus zeta square it would be, okay. So here that is omega n and omega n gets cancelled, and here that is zeta, for zeta you need to solve, that is zeta equal to 5 into 2 is 10, that is 8.11 divided by 10 pi. Okay, so approximately you will be getting the answer as 0.35. Okay, so that is, just a minute, 0.25 it is, 0.25, that is 25% it is. So this is another kind of a question. So you are finding the more questions from the vibrations, gears and mechanisms especially. On very few occasions the questions from governors, camps has been asked. Large number of questions are from these 3 chapters only. Yeah, here the equation of motion, here let me write it. Equation of motion is 6x double dot plus 9x dot plus 27x is equal to 0. You are required to calculate the damping factor. So here this is m, this is c and this is k, and zeta you can calculate, that is c by 2 root mk it is. C by 2 root mk it is. So c is 9 by 2 times of root over, mass is 6 into 27. So if you calculate this, the answer would be approximately equal to 0.35. Okay, let's see another question. So here it says that determine the equivalent mass and the equivalent system's stiffness for the given system when x is the downward displacement of the block measured from the system, equilibrium position, and is used as generalized coordinate. Take I as the moment of inertia of the wheel. If we try to write the moment of inertia or equation of motion for this case, so here there is a rotational, the wheel is undergoing rotation about its own axis and this mass is undergoing translation, and there are 2 springs that has been attached. So these 2 springs are connected in parallel. So when these 2 are connected in parallel, the stiffness will be added. So equivalent stiffness is 3K and 3K. Option A and option B both are correct. Okay, as per equivalent stiffness. But if we try to calculate the mass, then here this is actually I. It is actually I. So equation here it would be I, that is inertia of this disc, plus mass of the point mass, that is mr square. This will be equivalent inertia into theta double dot will be the inertial torque, plus stiffness, that is 2 springs are there, that is in parallel. So here if you add up the stiffnesses, it will be 3 times of k, and perpendicular distance of the spring from the center of rotation is directly r, that is 3k into square of perpendicular distance into theta equal to 0 it is. So if we cancel out r, this becomes I by r square plus m into theta double dot plus 3k into theta equal to 0. So option A is the answer, guys. Okay, option A is the answer. So these are a few questions, guys. The questions from vibration, CAMS and other chapters can be dealt very easily. So these were little complex and required some reasoning. So I have taken that and tried to cover maximum. And prepare well for your exams. Thank you and all the best.